Our group set out to create an interactive listening experience that places a listener at the center of a virtual soundscape composed of musical instruments. With this new medium, we hope to enable musicians and producers to have more capabilities to create music that involves the user. Our work allows musicians to express themselves in dimensions that are not currently available in conventional listening experiences. Using techniques that have been improved over the past few years with the rising interest in virtual reality, it is possible to modify an audio source to make it appear to have a specific location in space. As an incremental prototype, we set out to show that we could easily and quickly translate head movement into changes in audio parameters. By relying on existing technology such as an Arduino and a digital audio workstation, we were able to rapidly create a working prototype. We accomplished the head tracking in our mobile application in 2 ways. The user can either use the built-in sensors in their iPhone, or they can use our wireless head tracking module. In this module, low cost and latency constrain the design. In looking at communication technologies for our low latency head tracker, Bluetooth appeared at the outset to be the convenient solution, yet further exploration proved its latency to be unacceptable for our purposes. As is shown in the field, latency greater than 60 milliseconds in an audio head tracking experience creates noticeable ghosting effects where sounds appear in the wrong location. Ultimately, we used Wi-Fi to connect the head tracker wirelessly to the application as it meets our latency and cost requirements. When exploring how to track the user's head movement, we realized that we needed 6 axes of rotation so that the user could move their head in yaw, pitch, and roll directions. After running into limitations using a 3-axis accelerometer, we used an inexpensive inertial measurement unit with an accelerometer as well as a gyroscope to send head tracking data to our microprocessor. Although the initial inspiration for this app was to place the user in the middle of a band, we found that this did not consistently produce an exciting listening experience. Part of this was because the spatialization engine that we used did not have a lot of parameter options. We chose to additionally map the rotation of the user's head to position within the soundscape. This significantly exaggerated the interactive effect of the user's motion. In the future, we could map different attributes of the user's head motion to audio effect parameters other than spatialization, such as reverb or delay. We hope to give artists the opportunity to create immersive, interactive spatial soundscapes and allow them new room for creative growth to change the way consumers interact with music. It is because of our experience as electrical and software engineers and the advice of our mentor Alex Coleman that we are able to produce a low-cost solution that may have the capability to enable musicians to produce new forms of music, and we are excited to see where these ideas will go in the future.